Hello? Hello? Are we live? Hopefully we are. Let's see. Are we live? And there we are. Okay, good. So, today I want to do a little bit more work on Compactor. So last time, let's see here. Last time we did quite a bit on the binary stack. So, I've got the. Just give me a second. I have the wrong title. And description as well. Okay, hopefully that has the right title now. So yes, we are working on Compactor, not on PDF stuff. That will be another day. I'll try to do that. Just realised, isn't that the Haskell thing? Yes. I think it is. Anyway, that's not what it means here. But last time, did some work on the binary stack struct, which is my idea for how to turn the stream of enums into bits. Though I was thinking here, instead of when we are doing the encode, when we do this to vec tree path, instead of returning that, we could just return the binary, because there's no reason to use a full enum there, because as far as I know, because of the way that Rust and lots of other things lay out memory, everything has to be byte aligned. So even though this left-right enum here contains a binary value, left or right, it will take a whole byte of memory, I'm pretty sure. But I think you'd also have I'm not sure how much it would store. Well, I can test this, because we have so what we could do, I was looking at this before. So if we have an enum with two options, it takes 1 byte. If it's 3 options, it still takes 1 byte. 4, 1 byte. So I suppose the question is, will you be able to? How many do you need to have? So let's see if you can have 9, because I think if it's just storing that as a number, then you should be able to have you should be able to have 255. The problem is, because we've only got 2, so all that is wasted memory, and because we've got a vector of them, that we're using 8 times as much memory as is required. So that might be when we do the encode, what we could do is if I do some more work on the binary stack type, what we could do is we could encode just with that, because where do we actually write to the I don't remember. So text just map code, and this right, I see. Right, I see. So yeah, I'm not exactly sure. You could probably do that when you're decoding it, but you'd need to do something more sophisticated here, because at the moment what we've got is we have a vector of vectors of enums, and then they're being squashed together. But there's probably a lot of allocating for that to happen, because every time this clone needs to do a memory allocation, and then if you're doing a long, it still shouldn't take that long. I definitely soon I will look into how, because I think it was even on 1,000 the test was taking a very long time. So I don't remember exactly. On the long one, it was. Did it finish with 1,000? Right, so 1,000 was quick. Well, I suppose what would be interesting to do would be to write to figure out how long each iteration took, and then to figure out what order it runs at. So that took 10 seconds. The previous one took 2.5 seconds. So if we then increase this to 4,000, I suspect that this will take 40 seconds. Or, well, we'll see. But if it does, it seems like it's sort of an n squared type thing. But anyway, in order to be able to switch from the vector of enums to using the binary stack, we need to... Where are we? I've lost it. Yes, we need to change the way that the code is stored. Indeed, it did take 40 seconds. So I'm going to suggest. I don't know why 1,000, because 1,000 never finished, and I was going for a couple of minutes, and if because 1,000 took 2.5 seconds, so it should be 100. Should be about 5 minutes, 4 or 5 minutes. So maybe I just didn't leave it that long. I'll try again at some point, but it does need to go a lot faster. So instead of doing this, what you would have to do would be to take the code would still be fine, but instead of instead of adding them to, well, because there's an iterator of characters, and then I'm mapping them, I'm replacing each of them with the codes and then flattening with them. What I'd need to do is I'd need to iterate over them. I'd need to do a loop, and then I would want to go over each of those things. Then I'd want to push that onto the stack. So it would be more of a reduce type operation. So hopefully that will be faster, but that's an interesting. So the first thing that I'm going to do is I'm going to do binary. Are you supposed to I'm not sure exactly where to put it. I suppose I could just put it in utils instead of making it its own. Let's see if there's what there are to put types in Rust. Is there any wisdom? So no, what I want is creates it. No, this is the reference modules. Yeah, it doesn't say where you should actually put stuff. Oh, a union is just a struct, I guess. Anyway. So I think I will just call binary stack. And then let's .rs. That would be helpful. And then what I want to do is I want to do pub mod binary stack. That should have a snake. So what should it should have a snake case name? But if the module just has the type in it, then I'm not sure. It doesn't matter that much, but it's so let's see if there's anything else. So I could also make a just call it something else like types. But so let's see. I don't think. Haven't really looked into workspaces. That might be interesting. But yeah, what I'm mostly interested in what to actually name them. So I guess because in other libraries, I think I've seen that. I think I'll just leave it for now. So I think I need that, and let's copy all of that into here. You can get rid of that. Okay, that looks fine. So we can just get rid of that. So we've got the export there, and then we just need use compactor binary stack. I mean, I suppose it makes sense to put that under utils. I'm not sure. I'll think about it, and I might move it there later. But I also like, especially as it's got quite a lot of stuff, I like having that in its own file. So let's just check that still. Oh no, that's not what I meant to do. Let's cargo run. So yes, I think that was that's looking good. So now if we go here, because I think I'll just change this back to 1000. So now I've got, so that's displaying stuff. So I suppose we could also, what happens if we do this? Excellent. So what we should do is we want to be able to read at the read what the current bit is. So, but we want a method so there's a differences when we're writing, we want to when we're writing and we increment the pointer past the end, we want it to go over. But when we're just reading, we might also want to increment the pointer, but in that case, we don't so I'm just thinking, if we're reading, then we don't want to push more zeros onto the end. The other problem is you wouldn't be able to read while it's mutable, which seems annoying. So I'm just thinking. So I suppose let's just, for now, I might also split these out. If we do impl and then do binary stack. So this is writing methods. This is sort of general init methods, and then we can have another one and this one we can make read methods. So then I can do public function read, which just needs a reference to self. And that is going. So then the question is, what do we return? So I don't know whether you can, because there might be some way of sort of giving a type that you would like it to output that implements some trait, which if you have some enum with two branches, if there was some way that you could mark which ones you wanted, I'm not sure, but at the moment we just output a bool is the easiest thing, I think, and we can think about any other intricacies now. So what we want is we want to find let's do let byte equal self dot bytes, and then let me byte pointer. I don't know, is there any how much benefit of well, is there any memory loss using a struct over a tuple? Because it should go away at compile time. So if I have a struct foo, and then I have one is going to be a usize, and then we're gonna have a u8. Ooh. Then oh, that's just warning. 16, which 16 bytes. So a usize usize is 8 bytes, and a u8 is 1. So if we have a tuple of usize u8, So the usize is 8 bytes. That makes sense because it's normally 64-bit. But I guess it's trying to but not losing anything with a struct. So what I think is that we should then here do struct BS pointer. I mean, I think that makes sense in the context. Then we have byte pointer, which is a usize, and the bit. I'll just do the bit pointer, which is a u8. Though I don't know whether it would be, because it's not really a pointer, it's more of a mask. So I think it might be clearer if I just say that it's a bit mask. Okay, so then in here, what I can do is I can do BS pointer like that. So I guess it would be easier just to implement into, but let's see. Or I could just make a new, I mean, it won't get caught. I don't think it really matters, but it seems I'll just yes, pointer. So I want, doesn't need to be, this is just an internal thing, so I think from is best, because what this is going to be byte pointer, the U size, and the bit mask, which is a U8. And then this is going to return self. So then all I need to do here is BS pointer from excellent. So then here what I want to do is do self dot pointer. I think it's just gets confusing when it's harder to read when the because pointer is so long. So that is the only reason. So here we want self dot pointer this before was we want the byte pointer. And don't need those. So the same thing here, byte pointer, we just do that, and then the bit pointer is just going to be here, is going to be bit mask. Oh. Right. And then here, so dot one is the bit mask. One error left. So pointer.0 is byte mask, and then this is going to be bit mask. And it still works. Excellent. I think it would be good to put some tests on later. So right, so for the now we want a read method. I think that's, yeah. So we've got the byte, and then to read it, we want to AND it with the bit mask. So we want to return if byte and bit self dot pointer dot bit mask not equals 0. Oh, don't need the if for this. So at the end, if we then do let's try dot read. And the reason for that is it what happens when you push a bit is it increments the pointer second, which is what you need it to do because the pointer starts pointing at 0. So and there's I suppose what you could do is you could do a read offset. That might be, so let me, if I read offset and then I do offset and then this is a that would also have to be by a that's tricky. Should I, because I think the BS pointer is internal implementation. I don't think that should be exposed to the API. So I think what we want is just a number of bits. So this is a U size. So this will offset is in bits. I think no, it should be an I size. I think that the and there should also be this should be an option. Because we just want it to return none if there's nothing at the index provided. I think that's fair enough. So Yeah, because you want to be able to work both ways. So then let's do, is there, there should be a way, I'm pretty sure there's a method or a function to get both the quotient and the remainder, because I think that's the right. Oh, it looks like. I think that's only doing one instruction to actually do it, because that's the because on the CPU, the instruction that you use to get the quotient to do a normal division and to get the remainder is the same instruction, but depending on which one you want, you just copy a different one out. But it seems like the compiler is smart enough to optimize that away. But now, so what I want is, I just want to make sure, because I always get in I always get mixed up between the remainder and the mod. No, there's some language that has remainder as a so if we, because for if we have a negative number, say minus if we have -5 mod 8, what's that? I want that to be -5. Oh, in the closing bracket. Is that going to be -5? It is -5, and if this is -12, it's -4. So that is good. But if when I do a bit shift, I just need to make sure that it wraps. No, it won't. Because the problem is, if I'm at the first bit of this byte, and there's, let's say, an offset of 1, then I'm going to go into here. So really I need to increment the other pointer. So I think this is actually more more complex than it seems. Not as straightforward. So I think I might couch that for now, because what I'd need to do is I'd need to do the bit offset first, wrapping. And then I would need to store if there's a carry, so either -1, 0, or +1. And then add that to the byte offset. What I could do, very crude for now, just to sort of check the basic functionality, is I could what I could do is I could change this to read previous, and then in here, I want to do no, I'm still just using read. I want read. So this, sometimes it will show, it will be wrong. But here we are. True, false. Yes, so on the first write, because when the bit's in that first position, it's not going to actually read from the previous byte. Which is fine for now. That just to show that it works. But here we get what we want. False, true, false, true, false, true, true. Yes, because at this point the pointer is pointing to that 0, and when it gets shifted, it gets right. Yeah. Yes. Okay. So I don't think that implementation of the function is actually useful yet, but so I think I'll just comment that out. So one interesting thing to do would be to implement an iterator for this, which I'm not sure how to do. So that might be an interesting thing to read up for the next time, because if you're decoding this, because what we should be able to do is, if we have a binary file that we want to parse, you should just be able to take the whole array of bytes and stuff it in to the binary stack. I'm not sure whether stack is the right term. I need to think about that. But anyway, just thinking. Then we'd want to iterate over it. So, I mean, the easiest way would be to have if you wanted a sort of owned iterator, then you could just keep it and you just increment the read head, the read pointer each time using the increment logic. So what we might do here is anyway, so you could either do that, or you if you wanted an iterator that was a mutable reference to the original oral reference, then you'd probably want to create some other iterator thing which held a reference to the array of bytes but had its own pointer. So that means it could increment its own pointer and the pointer of the original wouldn't be affected. So for iterator, the main thing you need is next. I think that's how you... So if that's the case, that would be quite quick. But this increment pointer method we'd want to change. We want to change because if it's a this one adds to it. So increment pointer, it's an internal function, so the name I just wanted to be clear. And expand. I guess that sort of makes sense. If I come up with another name, I'll rename it. So right, so define the sequence. So impl iterator. So the type, so in this case the type will just be a bool for now. And then here we define the sequence using right, yeah, that makes sense. So the next, so then we return an option, let new next. Yes, okay, that makes sense. So what I think we'd want is, we'll put it here, impl iterator for binary stack. We'd want type item, which would be bool. I mean, I could alias that to bit, but I don't know if that helps at all. So then you want function next. Oh, that's nice. So we would, can we do if I do self right, it's not a member of the right, so I'll just put another so what this is going to return is a result I suppose it could just be an option So this is just increment pointer. That's all it does. And then, right, let's just do. Much better. Okay. So if it's 1, then we don't want to do that. But we then want to do another check that if so if we're at the end, if the self dot bytes dot len, so that's 3, equals, right, so we've already incremented the byte pointer, so if they're if this is greater than or equal to self dot pointer dot byte pointer, we want to return none. And then this should be some unit. And then in the next, or I don't know whether it would be because what we basically well, what I suppose we can do is that the no, we don't need to. No, that's fine. We don't need to do this check here at all. We just need to not push those bytes. That's fine because we check in the read. That's when we need to check. So this needs to be an option because we can always increment the pointer, but we don't always know that it will be pointing to something valid, which is the way that it needs to be for the iterator. Right, so our read is always an option, as opposed to the increment. We can set the pointer wherever we want. We just never have a guarantee that it's pointing at anything valid, which is fine because we always but that's not great either, because what really we want to be able to say whether or not the pointer is valid. Because we basically it would be a lot nicer if the read method was infallible. but I suppose there's not really much point because then the problem is if you I suppose you could also have the check just happen in the next method. It could check if the byte pointer equals the length of the bytes, then it wouldn't work. But I mean, I suppose that's a pretty simple check because the length is just something in the vec struct. It's just one of the fields. Yeah, because it checks whether or not you're indexing into memory that is uninitialized, or at least that doesn't have anything in it that's out of bound. So that should be pretty quick, I think. So I guess it would, at least for now, I think it would be easiest just to say if what is it? So if the self dot bytes dot len is that's not a I thought that would be anyway, that would be fine for now, is greater than or equal to self dot pointer dot byte pointer. Then we want to return none. I think it would be nicer if I did this and then I did else. Oh, no. And then just put this in sum. So then that makes this really simple, that all we have to do is we want to increment and then read. So we want to increment self.increment pointer and then self.read. And that should be fine. The only problem is that then you'll be, so then we'd also want so what we can do now is instead of that, do for bit in bin. That should be fine. Then we does not need to be mutable. We still want to do this. We just don't need that. Binaries. Huh? Yeah, because it starts at, where are we? Let's for now in the read, let's so we want self dot bytes dot dot len, and then we want so then this will be, this is the pointer, so this would be self dot pointer that's weird. How did that happen? Alright, self dot pointer dot byte pointer. Right, that makes sense. So I'll just, what happens if I put byte pointer? So if the length is greater than, oh! Ooh, yeah. Right. Yes, that's the problem. Ooh. So that's working now. Right, okay. So let's try again. I've got rid of all the. So now in here, let's do a so pointer. So then I'm just going to do self dot pointer equals BS pointer from 0 how can you is there a way to write a binary number? So can you do something like that? Say often in the front. Maybe you can't do that. Oh no, it says integers can alternatively be expressed using hexadecimal, octal, or binary notation. Prefixes, so when you need 0b. Good. So if I do excellent. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So let's try this one, and then let's try bin dot reset pointer. Yes, so that resets the pointer, which is excellent. So okay. So what else? So we've got the iterator, which is pretty good. I look into how to do the into iterator. The next where are we? The next thing that I would like to look at is in the nodes here. We have there's in particular there was the Huff node, which has a frequency and a value. So I was what I was thinking is that I don't think it would be terribly difficult instead of just requiring a Huff node. I think all the other ones are fine, but what I could do is I could replace I could keep Huff node, but I could put that Huff node frequency, for example, and then I think I'll do that. So if I F2, F2, I put like that. So then I can what I can do is no, that's more complicated because no, that's fine because that's on the import. But no, that makes it more complicated because my idea was that that frequency is only really required when you're building the tree. After that, you don't need it. So you don't really you don't want to put it into the not database. What do you call it? You don't want to put it into the file. You don't want to store that. So my thought was to try and make more of it generic. But what I might just do is, if I have the encoding work on it with frequency, because there anyway, there's no point getting rid of it, and then I make the decoding work without the frequency, and then I just we serialize it into the file, we just don't include the frequency data. But all of the other types will be the same. So where are we? So the Huff value and the cons are no, the connections will have to be, that will have to change. The value is fine though, and the tree path is fine. Though, as I say, I think it would be good to have a to do this to output the binary stack, or maybe it's more like a stream. But anyway, I think the next thing to think about is how to encode or how to store the structure. So I've been, and there are probably established ways to do it, but I like thinking of my own solution. So the tree basically looks like this. And it branches like that. So what I was thinking is I could, because there's two things, is that there's two parts. There's the structure, and then there's the values that are at the end. And I'm not sure exactly how to include both of them, because what I could do, for example, is use some kind of graph or tree traversal. For example, you could go to each left node, and then you could write each of those values down. But then you need some way to indicate how it was actually structured. Let's see. Because here they were traversing it with a path. So if you had I mean the sort of easiest, the one way to do it would be to have let's say to allocate a certain amount of space. If we're assuming bytes, you can only have a maximum of 256 of them. So if in the worst case scenario, if you had a tree that was like this, all the way down, you would need, well, I suppose what we could do, so in the, probably isn't, but one way to do it is in the header you could say that each symbol is given a certain amount of space. Let's say if everything could be accessed within 8 values, because that would give you 64. So for example, if it's just text, that's quite possible. Then you would have two bytes in the header per thing, and then you just have a path to each one. And I guess the way that you build, it seems like there must be a more efficient way, because I mean, the way that they're stored in memory, each node has either a value or 2 pointers to each of its children. But how to serialize that is what you could do. For example, is if you could say this is, you could have, so most of them won't have a value, so how to, so let's say each node is just a if you just go to each one is a pointer in the offset in the file, sort of how many bytes to offset. And then if you looked at the first one, because I was also thinking, if you could do something to capture the structure, then you could just have pointers somewhere else to where all of the actual bytes were. But I'm not sure that the pointers would be bigger than, because they're just bytes at the moment. They don't necessarily have to be. That's something that could that easily be changed, I think. But just assume they are for now. So I'm not sure how to actually serialize that, because we basically, at least in a moderately concise way, So if we have because yeah. So I'm not sure. As I say, it seems like the most basic one would just be to have, I don't know, let's say left. Then how would you say blank? So that's the other problem, is you can't really, because you only have 0 or 1 in this case. So yeah, you don't want to actually encode what the paths are. You need to do something else. Right. So I will think about that. Where are we with? I'll think about how to serialize those trees. So I think next time, possibly implement that, and also I want to have a look at clap and how that works for the command line argument parsing, because let's see, because I think that's really useful. It looks very powerful, so I think that would definitely be a good thing to do. So I think I will do a stream on that, possibly under the auspices of Compactor or just generally, and I'll think about how to serialize the tree, and also I'll look a little bit into optimizing and if we can figure out what's taking so long. So thank you very much for watching. Subscribe for more coding streams and to see where this goes next, and I'll see you in the next one.